Okay, good afternoon, everyone. So I hope you're all doing well. I'm glad to see all of you. We're now 30. Usually we have a larger presence or attendance. Carol, it's good to see you. I'm happy that you joined. I know that you and maybe a few others have issues with respect to being able to attend classes, given the challenges of your circumstances. So I'm glad that you're here. Okay, so you're all well. You see my screen and you're okay. You're not bothered by the little bit the echo.
Yeah, it's fine.
That's fine. I'm not able to remove it. Let me just check that I don't have my, okay. Okay, so today we're starting a new concept, which is hypothesis testing. So for the coming 3 lectures, we're going to address hypothesis testing, and that lecture is divided into 3 parts. The first part, we're going to test hypothesis about 1 sample, and then 2 samples, and then look at the chi-square test and considering variables as qualitative. Okay, so what are the learning objectives of the lecture? First, you will recognize and know and identify all steps of hypothesis testing, define what's a null and the research hypothesis, the statistics, level of significance and decision rule, distinguish between type 1 and type 2 error in the hypothesis testing, explain the differences or know what's the difference between 1 and 2-sided test of hypotheses, identify the right procedure whenever we have an outcome and based on also the number of sample and the type of outcome, meaning that sometimes we are testing difference between 2 means, 2 proportion, so the outcome variable could be continuous or categorical, or sometimes we are comparing 2 samples and sometimes we're only talking about 1 sample as we're going to do today. And the last learning objective is how to estimate and interpret p-values. Okay, so going back to statistical inference that we talked about it last time. So remember that statistics is used once to describe data, summarize, display visually the data. So this is one main aim of stat or biostatistics. But another main role of statistics or biostatistics is to get the data from those epidemiological studies and then try to make inferences from the data that you collect to a larger population. When you took those study designs, all the epi study design, it is based on taking a sample of your population, collecting data on that sample, but most importantly is that you want to go back from the sample to the population, right? So you want to make inferences. So that's the word inference. Inference meaning conclusion from your sample to the larger population. So, and this is what we call statistical inference. Now, statistics, with all the tests and the procedure that you're learning, allows us to say that we can estimate with a certain level of error, allows us, like last time, to build a confidence interval around the estimate. So 2 broad areas of statistical inference, as also we mentioned last time, are estimation and hypothesis testing. What we discussed was estimation, and estimation means only I estimate, يعني in Arabic بقدر. So I estimate that the population parameter is X. I estimate that the population parameter lies between X1 and X2, which is the confidence interval. So estimation, you don't know exactly, let's say AUB population, you want to know the proportion who are smoking. We don't know, we cannot access all AUB population. I take a sample, I ask a random sample, random sample. I ask student, do you smoke? Yes, no. And then I come up with an X bar. So that's a point estimate. And then I can ask you, can you be 95? What is your 95% confidence interval of the estimate? So you can tell me that I'm 95% sure that the probability or proportion of smoking in AUB is between, let's say, 20% and 40%, or between 25% or 0.25 and 0.34. Okay, and then of course, so the estimate of the confidence interval is associated. So you have to have first the estimate, the point estimate, and if you recall what additionally, how we build the confidence interval, if you still recall. So if we are estimating mu, it's X bar, so which is the sample statistics plus or minus Z sigma over square root of n. That is called, do you still remember what we call this component? Anyone? Margin of error, right? The sigma over square root of n is the standard error. And the Z is the Z corresponding to 95% or 99% or 90%. Okay? I hope you still remember. Thank you, Nasreen. Margin of error. So I didn't pay attention. So margin of error. So that's in the statistic, in the estimation. Now, when we hypothesis testing is different. Hypothesis testing, I want to prove that, or I want to research whether the probability of smoking at AUB is more or less than 50%. So this means that I have a statement, or what we call a hypothesis. So I hypothesize, بفترض, so it's an افتراض. So I hypothesize that if I collect data from AUB from a random sample, this will give me a probability significantly less or more than 50%, depends on what I'm expecting. So hypothesis is like an expected answer. So I expect that if I collect data, the body mass index of AUB student would be less than, for instance, 20. I collect data and prove whether the body mass index is less than 20. So what is hypothesis testing? So you have a research expectation, a statement, and you about a population parameter meaning whatever statistics come from the population as a whole. You take a random sample, you collect data, you generate a sample statistics P or mu, and then you determine whether that sample statistics support or reject the hypothesis about the parameter. So is it true that AUB population has a proportion of smoking more than 30%? Is it true that the mean population of AUB of body mass index is less than 20 kilogram per meter square? So that this is hypothesis testing. So what is hypothesis testing? So it's a research hypothesis. It's an expected answer to your research question, which is generated about something that's unknown. So you sample the data, you analyze, and then you determine whether the research hypothesis that you have stated is true or not true. So what are the steps? So I'm going to take you through the steps. And once we finalize the steps, we would take the sample. But as I'm explaining the steps, I will also give some illustration, right? So in hypothesis testing, the first step is to state your hypothesis. What are your expectations? And hypothesis is of two types. The hypothesis that no difference, we call it null hypothesis. It's the null. Null yani zero. Okay, which means that, and we call it H of naught, H naught or H0. It means that there is no difference between what you expect and what you find. Or if we are comparing, for instance, two groups, male and female, it means that there is no difference between a male and a female. If the research hypothesis is about, let's say I do an intervention and I measure body mass index before and after, the null hypothesis would be no difference between before and after the intervention. While the research hypothesis, or we call it alternative hypothesis, so alternative, we call it alternative. So in most books, it's called alternative hypothesis. This is what's the researcher expect, what you want or what you believe to be true. So you wouldn't do a study to say there is no difference. Usually you do a study to say it's larger, bigger, there is a difference. So it's called more a research hypothesis, alternative hypothesis, or actually what you expect to find as a relationship, an association, a difference, a change. Okay? Of course, this is what you expect. This is what you want. Okay, but there's always one hypothesis that's called the null, where you expect no difference. So there is null and H0, and you have to state it. For instance, my example on the proportion of smoking. So let's say my H0, if I'm testing that the proportion of AUB students who smoke is more than 30%, and you come and say, doctor, we're saying too much. People are talking about very high prevalence of smoking on campus, and you want to check whether the probability of smoking is actually equal or more than 30%. So your H1 is the declarative, yani alternative or declarative. And you declare an association. So P is more than 0.3. What would be H0? P is equal to 0.3, okay? Or 0.3 or less, okay? What's the one-sided or two-sided hypothesis? So one-sided hypothesis is actually specifies the direction of the effect. Let's say we are looking at an association between a new drug, whether it decreases blood pressure. Okay, so the hypothesis, as it is stated, it's called the one single-tailed or one-sided hypothesis, because we are expecting a direction of the association. What do I mean by direction? I am interested in seeing that the drug decrease blood pressure. So let's say we have an old drug, mu old, and I have mu new. I expect that the mu old, which is the blood pressure, would be greater. Or I can say mu of new less than mu of old, meaning that the mean blood pressure of the new would be less. So this is expected direction. While if you do a study and you don't know exactly how the drug will work, whether it will increase or decrease, it will just affect blood pressure. So you don't have an a priori knowledge about what to expect from that new treatment. Okay, it's not like it's done to lower, but you are introducing it, and you don't know whether it's going to be better than the old treatment or not better. So you can just put mu of new is different from mu of old. So this means this is when we say a no difference. We don't know the direction of the hypothesis. So just as a term, so first step is to identify your hypothesis. And when you identify hypothesis, you should know whether you want it to be a one-sided or two-sided hypothesis. One-sided usually is more focused. You know exactly where the difference is. Okay, you have strong knowledge about the topic. However, the two-sided, it's more general, and you don't know exactly whether you're going to find the male to be larger than the female, etc. You just put a two-sided, and we call it two-sided or two-tailed. So two-tailed or two-sided. So I'm going to two-sided, that we call also two-tailed, a double-tailed test. One-sided is a single-tailed test. We'll see it also graphically. Now just view.
Professor, I'm sorry, but can you go back to the slide before? I didn't get the difference.
Of course, 1 second, but I need to just make it, okay.
Okay,
right.
take your time.
Okay, no. So are you seeing well my slides? Just as a question.
Yes.
All right, great. So one-sided versus two-sided. So let's say you are doing a study, and your study is whether putting a filter on generator, for instance, would reduce the amount of pollution, right? So if you want to test whether those filter, I'm talking about those environmental health students, whether it will reduce, and you want to make a research, so you pick up few generator in the neighborhood, you install filter, you compare to those who don't have filter. But what are you expecting in terms of your study, that the filter would reduce your the emission, right? So
Yes.
because you are expecting to reduce, when you set up your hypothesis, it will be one thing. So it will be mu of the emission. So the mean level of emission for generator that has a filter is less than the mean of emission for those that don't have filter, right? So this is called one-sided. Why is it important? We'll see in a bit. The two-sided is to tell me that I expect that the mental health of people because of the war will be affected by their gender, so male and female. If you don't know which way, which will have higher prevalence of depressive symptom or anxiety, you can just state that probability of depression among adults during the war is different between male and female. So this is a two-sided, because you don't know which, is it the male are going to be more depressed or the female? Unless, again, you start with the premise that that female have higher depression, and you want to prove this. So if you don't know which direction the research would go, so this is two-sided. Is it clear now?
Yes, thank you.
Okay, sure, thank you. So the hypothesis testing, so we state the hypothesis, we decide if it's a one-sided or two-sided based on your interest and based on what you know. And then step 2 is you collect the data. So you collect the data, you take a random sample to see whether the data that you collect from the sample support the hypothesis or not. So for instance, if we are testing for mu, which is mu is the mean body mass index in the population of university student, I take a sample of AUB student and I compute the X bar. So I average all the body mass index of the student in my sample. I would come up with an X bar, and that X bar, using that X bar, I can test whether it is true. The hypothesis is that the body mass index is less or equal, holds true, or not true. So step 3 is now on what basis I want to say that it is true or not true. On what basis? So on what basis to decide whether I have to believe or accept the null hypothesis, meaning that there is no association, versus the research hypothesis that says, or we call it also, Elna, what do we call the research? Alternative. Okay. This is the H1. So H0 is null. No difference. Okay. So on which basis? And what would tell me that whatever I see, so if I'm checking whether the mu of the population, so the body mass of the population of AUB is more than or less than 20 per kilogram per meter square is less, and I find an X bar of 19. So I take a sample. How would I decide that 19 is really, really less than 20? Just by comparing the 19 to 20? No, it's not that simple. I have to depends on the level of significance. So how confident I am in that particular answer. And then there's something called alpha, which is probability of rejecting H0 if H0 is true. So what does it mean? It means that for hypothesis testing, I always assume or work under H0. I work under H0, meaning that I would state first, let me say that H0 is true. What does H0 mean? Is true? It means that the mu of the population of body mass index is actually 20. It's not less than 20, it's 20. So how far should my X bar from 20, how far should it be, and with particular probability, to allow me to say, well, this is true or not true, whether to believe the null versus the research hypothesis. This alpha that you see here is a probability. So this is the probability. Probability.
So, Professor?
Yes.
Okay, so if we're saying that it depends on the significance, so we expect it to be 20, and if it turns out to be 19, that means the null is true. We accept null.
Let me move. I'll show it to you and can I finish the steps and then we'll do it together?
Okay, yeah.
So I will show you. So this is okay. So let's say we are collecting on body mass index.
Professor,
Okay. Yes.
can you repeat what H0 is true means? I didn't get it.
أنا هلا I'm explaining.
Okay. Sorry.
So this is the distribution of the body mass index, BMI. Okay, I take a random sample of 100. I expect that the body mass index is, is normal. Okay, what's the mean of this body mass index? If H0 is true, what's H0 for example? So H0 is mu is equal to 20 kilogram per meter square, and HA نقول إنه the student are lean, so it's less than 20. All right. If H0 is true, so you expect that your population of students belong to that distribution, this distribution, with a mean of 20. And then when you collect your X bar, so your X bar is here. X bar طلع, so you take a sample. So we took a sample of 100, and then X bar, 100 is 19. So what would I say? So would I say that this 1 kilogram, it means that yes, H0, HA is true? No, I would say, the way I think about it, I would say that any X bar between between -2 and +2 standard deviation from the mean, standard error actually, from the mean, any X here, any X bar, I would consider as if there is no association. It means there's no difference. So if you get an X of 21 or X of 18.5, as long as it is between 2 standard deviation unit, عم نحكي 2Z, if it between those two, this means that they are actually, it's similar. It happened that my X is 19. However, it's still under a population of mean 20, and therefore H0 is true. When do we start saying no, it's not correct? I don't think that the X of whatever is really different, is when you start getting X's here. So these areas from both sides are alpha. We call them alpha. So anything that occurs at the edge of the distribution, this means that it's unlikely that it is under H0. Again, you will see it all, but let me go on. I'm just explaining the steps. So let's see. So what we did is, first, so I collected, so I put the hypotheses, I collected the data and calculated my mean or my probability, and then I decide that anything that's 5%, at the very end, I'm going to reject H0. Reject meaning, when you say reject H0, what does it mean? The alternative is, when we
greater
say
or less
it's
than
true.
2.
Yes, exactly. It means that H1 is true, so you accept the research hypothesis. So what do we do in step 4 and 5? So I summarize the sample in 4. So I do a test statistics now. And I only computed X bar. Now I do a test statistics. We'll see what test of statistics is needed for this one. And then I compare my test statistics to a number to the decision rule, and then I estimate a probability value which corresponds to my test statistics. Again, keep in mind a probability that corresponds to the test statistics. And then I would say the conclusion would be that H0 is true or H0 is not true. And if H0 is not true, this means that there is a difference. It means that my mu is greater than 20 or less than 20, depends on my research hypothesis. So what are those p-values? So if I draw here is the H0, I decide that any value, so this is H0, all of it is H0, the mu is 20, okay? And I decide that any value here, so I will put it as, you remember the 95% confidence interval? Do you recall on the normal distribution? What is
Yeah.
the Z corresponding to 1.90 to 95%?
1.96.
Yes. Bravo. So minus 1.96 على Z. So if I convert this distribution into under the standard normal curve, it means that I have 95% of the means between minus 1.96 and 1.96. So this is 5%, this is 2.5%, and this is 2.5%. So these are the alpha I told you about, alpha. And when my alpha is on both sides, yani 2.5 here, 2.5 here, it means I'm looking at a no difference. So if I find an X bar of here, 16. So this 16, which is here, I can find its Z value. And based on the Z value, I can find the probability from the Z table or the T table. So p-value is exactly the probability of your value of the samples, the statistics. You estimate it, and then you say that of course, the smaller the p-value, the better. It means that you reject. So to reject H0, your p-value should be smaller than your alpha. وهلا بنشوفها. So let me just recapitulate. So you set up the null and research hypothesis. So H0 and HA, we call it, or H1 or HA, alternative يعني. You collect the sample data, X bar P, X bar 1 minus X bar 2. This is what you usually collect the data for. You select the test statistics to prove whether this X bar is truly away from the mean under H0. You decide on alpha, which is most of the time is 5%. You compute the test statistics and you compare to the decision rule. Sorry, هون ناقص. Decision rule, which means alpha. Okay, and then you draw conclusion and you summarize the significance. While doing your test of hypotheses, you have two things that you can commit, which are errors. So you have H0 is true or H0 is false. So again, in testing hypotheses, we are working under the assumption that H0, we work under H0, and then we try to prove that H0 is true or H0 is false. Accept H0, this is the decision would be accept. Okay, so do not reject, or we can say reject H0, so based on the data. However, when you do that, when you say it's not, if I go back to that drawing, again, mu here is 20, and then you get an X bar here equals 16. You decide that everything is H0, all of it is H0, but you decide that if you get something here, it's not anymore. You take the decision that H0 is true. Is that a correct decision? Not quite, because you still are under H0, right? You're still here. You're not yet in another distribution. but you allow yourself that probability of being error that we call type 1. So when you reject H0, while H0 is actually, so you reject it. While it is true, you say, I want to reject it, while it is true, the probability should be low. And sometimes H0 is false, so you don't reject H0, while the H0 is true, is type 2 error. That we will not address here, but just to know that when it is false and you don't reject it, that's another error that you commit that's really beyond the class or the level at an EPHG 203. But just to note that 2 errors are committed. You reject while it is not true, or sorry, you reject when it is true, or you accept when actually it's not true. So these are the type 1 and type 2 error. So let's take how to do it with one sample. Okay, we're going to consider first a continuous outcome. Give me example of continuous outcome. AMI, blood pressure, your grade as not as a letter grade, but numeric grade. Okay, and we're going to consider one sample in this today's lecture. So what I'm considering, again, hypothetical. First, this is step 1. I state my hypothesis. So H0, mu equal mu 0. This is always true and null. Okay, so one sample, continuous. I'm trying to see whether the mean of a certain population is equal to a certain normative value or a value that I set. And I want to prove that it's either bigger or smaller. Of course, you choose one of them, or simply non-different. So the first 2 are one-sided test or hypothesis testing, one-tailed or one-sided, and this is what we call two-sided. And depends, of course, on your research. What is it that you want to measure? The test statistics that you use to check whether the X bar that you have found, so you set your hypothesis, and then you take a random sample, and then you test whether the X bar that you took from your sample is far or not far from the mu 0. But you do a test, and what you do is you convert your X bar into Z. This is all what we do. And this is remember Z, it has a mu of 0, right? This is the Z distribution with standard deviation equal 1. So what you do, anything that you get, you convert it into Z, and the Z is X bar minus mu over the standard error of X bar. So this is the difference between your sample statistics minus your parameter, اللي هو mu 0, over the standard error of your statistics. When n is less than 30, we use the Z-test or the Z-table. When n is less than 30 and normal, okay, so the population is normal, we use the T distribution rather than the Z distribution. Okay. So let's take the first example. So that example is the National Center for Health Statistics report the mean total cholesterol for adult is 203 milligram per deciliter. What's this 203 milligram per deciliter? So they report, so they claim, we can say they claim that the mean cholesterol is 203 milligram. So that's mu 0. Sorry. Yes, please.
Is it mu or X?
Sorry.
Would it be X? Yeah, would it be X or?
No, it's not X because they're claiming. It's not based on
Okay.
a sample. They say we claim that mean total cholesterol in the adult population. This is what it says. It's not says like weaker. Now, if we, so what the question is the mean total cholesterol in Framingham Heart Study? So, so they took a sample from the study, and they want to see whether this is different than the national mean. So the question here is, the mu0 is the national statistics stat for cholesterol. So we're asking whether mu of Framingham is similar to the national. That's it. We're not comparing national to non-national. We're actually looking whether, so the national is like the norm. Yani at a high level, this is what we expect the US to have as a mean total cholesterol. So does the Framingham population have the same level as the population of the US? So what they did in Framingham, they took a sample and 3,310, which is much more than 30, right? And they collected data on cholesterol, and they found that the mean is 200.3. So what is it? This is my X bar. Okay, so X bar is 200.3 with a standard deviation SD equal 36.8. So what do we have? So we have the national as mu0. We have the Framingham, which is the, we want to check whether the Framingham is actually equal or what do you want, significantly different. So it's a one-tailed or two-tailed? So the question is the mean total cholesterol from Framingham is different than the national? Yes.
Two-tailed?
Two-tailed. Nasreen, I need other than Nasreen. Thank you, Nasreen. I really appreciate your engagement all the time. But I would like also to hear others, please. Yes? Okay, please speak up. Even if you say it wrong, it's fine. So H0, again, mu of Framingham equal 203. And the HA or the eta, it's mu of Framingham, different, only different than 203. So this is mu0. This is mu0. All right? Okay, now the test. So this is, as we stated it, mu 203, mu1 different than 203. The alpha is 0.05, meaning that this is my decision rule. Decision rule, it means 5%, yani bigger or smaller. So therefore, my 0.05 is going to be 0.025 here and 0.025 here. So, and inside is my 95%. Okay, and this is H0, and this is 203. So what I do is, what did I get from the data, from the sample of 3,000? I got what? 200, right? Right, ladies and gents? We got
Yes, 200.3.
200.3. So it's here, it's somewhere here. 200.3. So do I consider, so is my decision that 203 is really different than the 203? So what I do is I convert my X into how far is it from the 203 in terms of standard deviate, and in terms of standard error. So therefore, my Z, my test statistics for one sample, and again, you will be given those formula, would be X bar, which is my 200.3 minus 203. So if, of course, if I consider that H0 is true, it means that, let me see how far is it. Over SO is 38. Can you tell me how much is it? 38, maybe? Over square root of 3,000. Okay. So 36.8, 36.8, sorry, no. Sorry, 3310, and S is 36.8. So this value, we check it out, and the decision rule would be if this Z that I find falls here or here. So if it falls here or it falls here, my decision would be reject H0. If it falls under Z 1.96 and minus 1.96, where is it coming from, the 1.96?
The 95%?
Yes, from the alpha 5%. Yes, to get it is usually we look at the Z at the 95%. Okay, so since it is this 95 is on the two tail, so if you look at the probability here and inside 95%, so it is 1.96 here minus and plus 1.96 plus. Okay, so if the value of the test statistics lies between those two values, we accept H0. If it's outside those values, here or here, this is the rejection areas. Okay. So compute the test statistics. Okay, so let's see again. Now we're at the Z. Z is 0. My rejection is at 1.96 plus 1.96. How much the value was? 200 minus 203 is minus 4.22. Where does it lie?
After 1.96.
So it's here. 4.22 minus. So what do we see? What do you see? That it is less than the minus 1.96. Does it fall in the rejection area?
Yes.
Yes, so it falls in the rejection area, those that I'm highlighting, and therefore my conclusion would be reject H0. What does it mean, reject H0? This means that there is a difference between the mean cholesterol at the national level and Framingham. It looks like Framingham have lower mean cholesterol value. How significant is this information, or this this result? What is the So what's the probability associated with 4.22? Ladies, if you look at the Z, what's the probability of Z less than 4.22 in your opinion? Is it less than 2.5 or less? This area. Is it?
Yes.
So probability of Z less than or equal to minus 4.22, is it less or equal to 2.5% or 5%? ما قلنا الألفا is 5%, right? Is it less or equal or greater? Speak up. It is less. Less. Look at it. It's in the small area. So this means it is very, very unlikely that your X bar belongs to this H0. What does it mean? It's rare. It means it's rare. It means very unlikely that the mean of Framingham has a mean equal to 2.3. It belongs to another distribution with a different mean, which is H1. I don't want to complicate. So we say that conclusion is we reject H0. Why do we reject it? Because the minus 4.22 falls in the rejection area based on my decision rule of alpha 5%. It is less than minus 1.96 that correspond to the 5%. We have statistically significant evidence, and the conclusion would be it is statistically significant evidence that the mean total cholesterol is different in the Framingham heart study compared to the national data. Okay. Okay. Let's take another example. Okay, so example testing for mu, so the significance Z, so the critical value for two-sided. So if you decide that alpha is 20%, 0.2, the Z is 1.282. This is based on the Z table, by the way, guys. Sorry, oops. So if it's 0.1, the Z is 1.645, it is 5% is 1.96. So what we got is actually the last one on the table, 3.8. So if this is 4.2, this means the p-value is even less than 0.001. Is that rare or not? When you say probability 0.001.
Yes, it's rare.
So this, it means that you cannot have the mean of the population of Framingham under or similar to the one at the national. It means it's very unlikely, we say very unlikely / rare that H0 is true, true. And this means that this is called type 1 error. So my type 1 error, and if my error is only 0.0001, then I'm saying, okay, reject H0. Well, it's still very likely, unlikely, but still likely by 0.001. So that's why we say the type 1 error is very small. So type 1 error is
Can you
small.
re-explain that? Because my internet was bad and it was like
Okay.
glitching the voice.
It's okay. So when we get very high Z value or highest test of statistics, so we're still under H0, but we are at the tail, at the very end. And the probability of finding this under H0, and this is the 4.22. So its probability is very low, 0.0001. This means that it's at this point in time, what is my decision with respect to H0? I'm
It's
saying reject.
unlikely. It's
Reject. But still, there is a very, very, very small probability that we're still under H0, but we are accepting it. And no, it's okay. So this error,
possibly unlikely.
so that's what I'm saying. It's very, very unlikely that this value be under H0, but it's still, there is this small probability that's very small and that I accept as an error. And this is what we call a type 1 error. Type 1 error, we compare it to alpha. The alpha is 0.05. So this is much, much less than 0.05. And therefore, we do think that it's very significantly different than the mean of 2.203. And therefore, the mean from Framingham study is significantly different from Framingham. Of course, we did it on two-sided, that's fine. And we could have divided, put all the 5% on one side, but irrespective, it will always be the same conclusion, whether it's on one side or two sides. Okay, so now another scenario. So this is for the mean.
Thank you.
But let me tell you before going back. So this is this Z, this statistics Z. Okay, okay. Going back to, I don't know which slide number, but just to please be careful. So this statistics that we have just made, this is when the n is greater than 30. So we converted the x bar into Z because n is greater than 30. But when n is less than 30, my test statistics would be t, and then I would compare the t that I calculate based on the t of the 5%. So you use t table. So the value would be very similar when n are large, but when n is small, you have to look at the t with n1 minus degrees of freedom. For instance, okay, here is my t, right? So t is associated with n minus 1 degrees of freedom. So if n is 50, n is 20, and I want alpha is 5%, okay, so therefore I look at the t of 5% and N and 19. So it will not be 1.96. It will be, if you recall, greater than 1.96. So the value of T are greater. So just to note, and it will not be 1.96, what you compare with, it will be a T. So therefore here, if we had an N, not 3310, but N of 20, so N of 20, that the test statistics would have been T equal 200.3 minus 203 over نفس الشيء, so S 36.8 over 19, but we compare that T to a T of 5% and 19. So this is we call the critical or the decision rule, based on which you say there is association or there is a difference, or reject H0 or accept H0. So remember, your population should be normal if it's less than 30. If N greater than 30, you use the Z. Irrespective, you just pay attention when you are given an exercise. If N is less than 30 or N greater than 30, to do your test statistics based on Z or T. And the only thing that will differ is the critical, the T that you will put here. Here for Z, I put 1.96. If I had an N19, the 1.96 plus or minus would have been different. I will have to take it, extract it from the T table. Okay, so now the other scenario. So the scenario where I'm going to do another example and we'll open the T table and then we'll get the numbers from. So the new scenario now, the outcome is dichotomous. Okay, so like result of the surgery, it succeeded or it failed. Cancer remission, yes, no. Do you have diabetes? Yes, no. Do you like statistics? Yes, no. Are you happy? Yes, no. Okay, so dichotomous. And therefore, outcome is measured in terms of probability. Probability is the number of successes, if you recall. So a number of successes, sorry, over the sample size, right? This is the p-hat. So it's the same process and step, similarly to when we testing whether the mean mu equal mu zero, mu is different than mu zero. Now we're going to test whether p, the p-hat is equal p of a population that I'm interested in is equal to a certain number or a normative value, or it's different, less, greater, depends on the test that you are doing. So we're considering one study sample, the data on each participant, we measure the outcome, and then we will have a p-hat when this is my sample proportion. So this is my statistics from the sample. Okay. Now let's have an example. So the dichotomous is P. So usually we are testing for P. One sample, meaning I'm testing whether P is equal P0. For like the example I gave you, is the probability of smoking at AUB is more than 30%. So again, let me take this example before going to the example in the slide. So is probability of or proportion of smoking, is it 30%? So this is AUB population, and this is the claim. It's a claim. Yeah. I'm claiming, okay? As if I say, outside, I know from recent data that the national proportion of smoking is 30% among young people. Does AUB student, does AUB has the same probability of smoking among its students? So I take a sample of student and I check it out. So the H1 is P, then what do we claim? Less, because we have the non-smoking, a non-smoking campus, right? So the H1 could be P greater than 0, P less than P0, as I'm stating it for my example for illustration, or P different than P0. So it depends. So this is the two-tailed So I'm not interested in bigger or less, or similar to this one, or P greater. So I do a test of statistics. This is the test of statistics. So I take a random sample. I collect data on smoking. I compute the smoking in the sample, and then I do a test of statistics and compare it to a critical value or my decision rule. There should always be a decision rule where I specify my alpha, let's say 0.05 or 0.1 or maybe 0.001 to be more strict. Just as if you recall, when we did the confidence interval for probability and to be able to use the Z, do you recall well what we test? We tested whether NP0 and N minus P0 are greater than 5. Do you remember that specific condition?
Yes.
Okay, so similarly, when we do this statistics, whenever we are using Z, we have to check either if the N is large, especially in continuous variable, N is large, the sampling distribution of mean would be normal. If N is less than 30, we have to check the population, we assume normality, and then we use the T. For whenever we have an outcome that's dichotomous, meaning that yes, no, made of two outcomes, success and failure, do we have to check the NP and NQ? This is NQ, meaning that, like in that example here, I don't have the N here actually, but we will do it for the other example, is multiply the sample size by P0 and N1 P0. We can also do it with the sample statistics, not only with P0, but they should be greater than, equal or greater than 5, equal or greater than 5. And then I do my Z statistics and I compare the Z to 1.96, the critical value that correspond to alpha. So this is critical value that correspond to the alpha. So another example, again, national statistics, it's the national, I forgot what's the C, health statistics, reports that the prevalence of cigarette smoking among adults in 2002 is 21.1. Again, this is at the level of at the national level. This is the P. So this is my P0, 21.1%, or better written as 0.211. Okay. Now the question is the smoking in Framingham study lower than the national? So now I'm talking about the one-sided. So now this is H0 and this is H1 or HA. Is P of Framingham. Sorry. This is not P0. So first the P of Framingham. So this is Fram. Fram is less than 0.211. Okay, so again, based on the research question, is the prevalence of smoking lower among participants in the Framingham Heart Study? This is, if you recall, Framingham is a big cohort. It's actually a big town where they have recruited like 54,000 individual or 5,000, I think 54. And then they collected data on all health indicators, including smoking. So now we're asking, in 2002, is the prevalence of smoking in Framingham City, or that study that included a large number of Framingham citizens, is it lower than the national value that's reported by the National Census or Health Statistics of the US, which is 21.1? So I stated as such, H0 is the probability in the Framingham study is equal to 21.1, my H0, and my H research is, it is less than 0.211, because this is my research. This is my research hypothesis. Okay, so what they took is, this is N. So N, they took a sample 3536. This is the sample from Framingham. And out of those, we have 482 who reported smoking. So therefore, what's my P? 482 over 3536, which is equal to, it is equal to, let's see, 0.136. So 0.136 or 13%. So the question is now, based on the sample statistics, this is the sample statistics, can we say, because we take one sample, we collect the data, we get that P hat. So can we say from that P statistics that actually the prevalence of smoking in Framingham is less? So what do we do? So we stated this is the hypothesis. We just put it on the other head. We said alpha is the common one. It's like always we put alpha, most commonly used probability or critical area is alpha 0.05, because we don't want to make a lot of mistakes. So what we do is we allow 5% of being wrong. So is a one side, the 5% on one side. If two-sided, the 5% would be divided by 2.5 on the right and 2.5 on the left. So here, if we're looking at the Z, now the 5% is here. Okay, and it will correspond to a Z of minus 1.645. It's not anymore 1.96, because here now, based on the T, this is 0, Z is 1.645, okay? If we have divided the 5% into two, on the two tails, it would have been 2.5 from the right, 2.5 from the left, and my Z would be 1.96. Here, because the 5% is on one side, based on my research hypothesis, the Z corresponding to 5%, which is the critical, we call it critical value. Okay, it's 1.645. So now I collected the data. I have to transform my P that I found into Z value. Of course, you have to decide to check NP0, sorry, NP0 and NQ0 greater or equal to 5. Of course, is greater or equal to 5. We have N 3,300 something, right? So the decision rule, what is the decision rule? Is reject H0 if the Z is somewhere here. So this is my rejection area. We call it kill. Here is the rejection area. So if I compute a Z, any value of Z here, this means I reject H0. I'll put it again here. Okay. This is 0. This is minus 1.645. This is my rejection area, rejection region, call it as you want, which correspond to alpha 0.05. This is 5%. And then I compute the Z. So Z is 0.136, which is my probability of smoking based on the sample of 3,536. So this is P hat minus P0, over the standard error of P. Remember the standard error of P, right? You still remember, which is square root of Z PQ over N. But we use the P0 and Q0. So 0.21 times 1 minus 0.211, which is the Q, and this is Q. This is PQ over square root of N, 3536. So what we get is minus, sorry, I'm sorry, why, I don't know why these signs are not there. So minus 10.93. Where is minus 10.93?
It's above,
Oh, so
It's
way
outside the-
in the tail, right? So
yeah.
it's here, minus 10.93. So if just by looking at the, it's very important, and I think it's very useful to you if you just plot the curve, the distribution. So this is telling me, so I compare now this Z to the 1.646, 645. So the conclusion is we are in the rejection region, and therefore, what's the conclusion? Is that since my Z is less than what the Z critical, this is, we call it critical, it means that I reject H0, reject H0. I'm in the rejection region, which means that we have statistically significant evidence at alpha 0.5, this is the 1.64, to show that the prevalence of smoking is lower among the Framingham Heart Study. What's the p-value that correspond to 10.93? It's very, very small, right? And if I find in the table of the Z table, the probability of Z minus 0.93, you don't even have that value, by the way, in the table. What you have is the highest would be 4, so it will be 0.001. So the P corresponding to 10.93 would be less than 0.001, and therefore this is another evidence to reject H0. Rejecting H0 means definitely Framingham study probability of smoking is not equal to the national. It is based on the data much less than the national. It is actually statistically significantly less than the national. So we can say it. So probability proportion smoking in Framingham statistically, and you can put it all statistically significantly less than the national prevalence. مش إنه بس we see it and it happened to be less, it's statistically significantly less because it falls very low under H0. It falls very much here, and therefore it cannot be no difference. It's very clear that the probability of smoking in Framingham is very, very less and very significantly less than the national prevalence. Questions? Okay, so is that, and I hope that I was not rushing this. I try to like dissect the hypothesis testing into smaller lectures, so to make it easier on you. So is it good? So do you want me to produce a new slide and put something else, give you more examples?
Honestly, I didn't get the rejection well.
It's okay. Yeah, I will do it. Okay, so who was it? Okay. Okay, I'm going to just a moment. Going to try to lock here. Let me add a slide. And as I said, I'm not very comfortable with, okay. I want to add a slide. How to add a slide, how to get out of the slideshow. No, undo. Can you give me 1 second? New slide. Yes. Okay. Just to add there, I'm so much clumsy with the, okay. Slideshow. Share. Did I stop sharing? It's not sharing anymore.
Yeah.
I'm not sharing it. But yeah, 1 second. Screen, start broadcast. But I did improve, يعني, right? There is some kind of improvement in my performance and my use of the iPad. Please give me some
Yes,
encouraging
it's
words.
pretty, it's a lot more understandable when you write down and we can follow along with what you're thinking.
Thank you. I'm trying to do my best. I'm happy that I bought this one. Okay, but why it's not showing as a slideshow? Presenter view. Okay. So at least, okay, so let me tell you. So are we clear about HA, H1 and H0 and HA? Okay, no difference. And difference. Okay, so in statistics, okay, as a researcher, you want to find a difference. As a researcher, you want to prove, for instance, I want to go back. I'm sorry that I'm giving this example, but maybe you can come up with an example and I can do the illustration. Would you like to come up with an example of your interest, so not to impose on you always my research and any thoughts?
As a
Yes,
professor, I was
Yusuf.
looking for an example of like an
Yes.
interesting topic or something.
Yes, and you want to test a hypothesis. You want to do a research on, but on one sample. It's like checking a claim. And for instance, okay, so let me take an extreme example, not about smoking, maybe about smoking weeds, okay? Marijuana. So we don't, let's say we don't have data, okay, about the use of young adult of marijuana, right? And then, but there are people claiming, or just by observation, saying that a lot of people do marijuana, and 50% just throwing that, more than 50% of the young adult in Lebanon, they smoke marijuana. So, okay. So, and then you want to check that claim. You want to do a research on a sample of young adult to check that claim. It's a claim, it's a research. So the claim would start with two hypotheses. One, okay, which is H0, is that probability of marijuana, okay, is 0.5 or less. This we'll put it no different than 0.5. While your H1, what you want to prove is that probability in the adult people in Lebanon is, based on all these claims, is actually more than 50, more than 0.5. So what you do when you want to check, you take a random sample of young adult. So let's say you decide to take n equal 1,000 people age 18 to 24, for instance, and then you do a survey and you collect data and you ask them. The question is, smoke or don't smoke? And the P is what, so you collect the data and you find that out of the 1,550, they reported smoking, irrespective whether they're saying the truth or not. So don't come to me telling maybe they're not telling the truth. So let's say 550 over 1,000, right? So how much is it? Point 50,
Your
right?
voice was glitching. I didn't hear you.
Sorry, Harry. Okay, so I'm saying we get a sample of 1,000. Okay, so did you hear me before?
Yes, the explanation about the case. Yes, I heard it.
Okay, so we took a sample of 1,000 people 18 to 24. we administer a questionnaire, including one of the question, have you ever smoked marijuana or are you currently smoking marijuana? Yes, no. So smoke, yes, no. And then based on this, we found that 515 are smoking, reported smoking out of the 1,000. So what can we check? What can we, calculate is
The
the
proportion.
statistics. Yes, proportion in the sample. Now the question is, can you say, based on this, that that young adult have higher prevalence than 50%? So is this claim true?
How
Okay,
can you find out? I don't know.
okay, okay. So this is, we do a test of hypothesis. So that the null is that it's 50% or less.
Okay.
And the alternative that you are looking for is whether it is more than 0.5. Good?
Okay.
So if it is 0.5, so if I consider that the marijuana use is 0.5, it means this is my H0. It means it has a mean of
Wait,
0.5,
so
right?
we're having
If
a
I
one-sided
accept, and if
hypothesis,
I
right?
accept it, if I say, let's say H0 is true, it means that my population belongs here. It's here, okay? But where do I start saying it's no more H0? I put a decision. I say
Find the
any
Z.
value. Yeah, no, okay. So I would say, so I decide that my alpha is 0.05. The question is greater. So I want here this value. So I would say any value of X bar of P that falls here, okay, it means that it does not belong to H0. So I cannot best compare P to P. What I do is I compute a test statistic. So this P, I would translate it or transform it into Z. So now I have another H0. So this is now H0 also. But in terms of Z, with Z equals 0, sorry. Oops, what happened? 0. And then here is my rejection region here. So this is P. Here is Z values. So what is the Z value corresponding to 0.05 at one level, at one tail? It's
645.
1.645. Yeah, excellent. Now what I do is I compute a test of statistics, which is, sorry, it's too crowded, but I'm going to try to see if I can erase some of it. That's how to get to that. بس خلينا هيك. Let me see. Can I erase this? No. Okay. I haven't. Okay. Let me not mess up. So I would find Z, which is 0.55 minus 0.50, which is P0 minus P, so it's P minus P0 over square root of 0.5 times 0.5, which is P times Q over square root of 1,000. I will do it on my, so you can do it with me. So 0.55 minus 0.5, okay, divided by, okay, 0.5 times 0.5, okay, over square root of 1,000. How to get the square root of 1,000? Square root of 1,000. Can you do it and
Wait,
let
are
me
we
know so we can
using
check?
the proportion
We can
formula?
check together now. So what would be Z? Did you do the calculation to find Z? At least one of you would, please, can you do that so I can check if it's correct?
Is it 3.16?
So let me check. Equals, oops, can divide by
Wait, why
0.
did you put radical on the n?
Because this is, okay, let me show you, sorry. Here is the formula. It's P, so it's P. This is what, okay, it's easier to do it here. So this is 0.055 minus 0.5, which is P0 over standard error of P, square
Yeah.
root of P0 0.5 times 0.5 over
1000.
1000. So how much is it?
So 3.16.
3.16. Okay, so let's go back to, so where it is?
So it's
3.16.
in the rejection.
where?
Yeah.
In the which
Rejection.
area?
I mean,
Rejection. So what
the
is
rejection.
yes, so what would I say? So is the probability of the smoking marijuana
So-
greater than 0.5? Or is it equal to 0.5?
Yes.
If I'm rejecting, it
wait.
means
It's
it
great.
is greater than 0.5.
Yeah.
So
Yeah.
one other thing I can do is finding the probability associated with 3.6. It's going to be also less than, and here is all 0.5. So the
Okay.
probability, it will be much less than 0.05 because it is at the border, at the
So
tail.
Professor, if it wasn't in the rejection area, that
Yeah,
means
okay,
there's
if
no
it's here,
difference?
if the Z that you calculate is here,
Right.
if it's
So
here, it means
H0 is
that
true.
it means that there is actually H0 is true. What does H0 is true?
Yeah.
It means that whatever you see
There's
as
no
difference, يعني هال 0.55 or 0.51 is due to chance. I don't know if you have ever heard it. When we find differences in the sample, but statistically is not, it's still under H0. The conclusion would be that except H0, the population of adult that you have sampled, its probability of smoking is not different than 0.5. And whatever we saw in the sample is actually a mere chance difference. Okay, when that difference becomes bigger and bigger and bigger, the bigger the difference from the in terms of Z or in terms of absolute difference. So as if you have 0.5 and then you get a 0.7, okay, the 0.7 is really large, right? But the most important is how far is the distance in terms of Z, in terms of standard deviate. So the more it is towards the tail, the more likely that the difference that you see is a true difference. I hope it's a little bit, I hope I'm not complicating issues. But I mean, the more you practice, I hope that the more you will find it easier. Just keep in
Yeah,
mind.
it's starting to make sense.
Great. So you need to always think about your the nature of your variable. Is it continuous or is it dichotomous? So are you using a mean or are you using a p? Are you looking at the hypothesis one-tailed or two-tailed? If you're looking at dichotomous, did you check your NP and Q greater than 5? And if you have a dichotomous, check if n, pay attention that your n is greater or less than 30. If it's greater than 30, you use the Z table. If it's less than 30, you use the T table. I hope it was, it's not an easy concept. All those that are not easy concepts. And thinking about, let me work under H0 and then reject H0 is not actually evident. Yeah. But anyway, the more you practice, the more that this would make sense.
This last
So-
example, it
Yes.
clarified everything.
Great, great, I'm happy. Okay, so I will share the recording and I wish you a good afternoon.
Professor,
I'd like to tell you something, but before I forget, that we would like to encourage you to come to campus. We're not going to pressure you, no social pressure, no pressure at all. But if you can, and if you'd like to make it on campus for the practical session, that's fine. If you don't, you're not penalized. You're not at a disadvantage. We just want to see how it goes and try to test the water. So far,
Professor.
we've decided that everything is online for the lecture, but if you can make it for the lab, it will be hybrid. We're going to make it hybrid this week and see how it goes. Yes,
Sorry to interrupt,
yes,
but
yeah.
I wanted to ask, are we going to have an assessment this Friday and Thursday and Friday?
It's an assessment. It's like no TBL.
But the
So-
thing is
Yes.
we need to study the material before the assessment. But HCOM,
It's
and I
not
don't
an
know.
issue of assessment. We're doing like the exercise. It's an exercise that you do in groups, right? It's not
Yes.
an assessment, it's an assignment.
So just one question.
Yes.
So instead of the TBLs, they're going to be assessed.
Can I stop the recording? Okay. Screen stop. Yes. I'm not sure it is still recording. Yes, please. It's still recording. I want to stop the recording. You can ask your question, it's fine.
Okay, instead of the TBLs, we're going to have assessments just like last time, and we have to submit them 1 hour after the